Hello, welcome to RCC's Math Tape 095, Solving Word Problems by a System of Linear Equations. The two types of word problems we'll deal with on this tape are direct translation problems and investment problems. The direct translation problems simply translate sentences directly from English into mathematical sentences, equations, and the investment problems will deal with finding interest on an investment, something all of us need to know about. So let's get started. The objective for this tape is to use a system of linear equations to solve direct translation problems and investment problems. In order to use the system of linear equations, we must translate from mathematical sentences, from English sentences rather, into mathematical sentences. When we create the system of linear equations, then we can use it as the mathematical model and solve the system to solve the word problem. Our first task then is to translate from English to math. Our second task is to work the system of equations that the mathematics gives us. Let's take a look first at an example. This example says the sum of two numbers is 30. The sum of two numbers is 30. 3 times the larger is 6 more than 4 times the smaller. Find the numbers. The sum of two numbers is 30. 3 times the larger is 6 more than 4 times the smaller. 3 times the larger is 6 more than 4 times the smaller. Find the numbers. We noticed right away they were talking about two numbers. This says the sum of two numbers. That means when we find the numbers, we've got to find two of them. So our answer must involve two numbers. We're told two things about those two numbers. One is that their sum is 30. Remember that sum means add. Sum is the answer in addition. And so when we add up the two numbers, we get 30. The other thing is a more complicated sentence. 3 times the larger is, you recognize is as a key word for equals. 3 times the larger equals 6 more than 4 times the smaller. This gives us a second sentence about the two numbers. We then have two sentences involving the two numbers. The names of the numbers are the larger and the smaller. Let's give letter names to those two numbers, the larger and the smaller. And I'm going to choose to let the larger be represented by X and the smaller be represented by Y. The larger is X, the smaller is Y. Now let's make our translation about the two numbers X and Y. Our first sentence says the sum of the two numbers is 30. That means the larger plus the smaller will be 30. So that gives us the equation X plus Y equals 30. X plus Y equals 30. Now this next sentence tells us 3 times the larger is 6 more than 4 times the smaller. 3 times the larger would be 3 times X, 3X, is equals 6 more than means we add 6. I'll add 6 at the end of this. 6 more than 4 times the smaller. The smaller is Y. 4 times the smaller would be 4 times Y, 4Y. So my two sentences have been translated into two equations. The sum of the larger and smaller is 30. 3 times the larger is 6 more than 4 times the smaller. And so here is my system of equations. X plus y equals 30. 3x equals 4y plus 6. Well, in order to solve this system of equations, I need to have the equations in the same form. Let me go over to the side and write x plus y equals 30 and 3x equals 4y plus 6 in the preferred order. I prefer to have the x term, then the y term, then the equals mark, then the 30. So the first equation is the way I want it. The second equation has the x term, then the equals mark, then the y term, and the constant. I would like to remove the y term from the right-hand side so that it will show up on the left-hand side. Remember that to remove 4y that's being added, we simply subtract 4y. And so the second equation is 3x subtract 4y equals 4y plus 6 subtract 4y. This gives us 3x minus 4y equals, the 4y's cancel, and we get 6. And so the two equations are x plus y equals 30 and 3x minus 4y equals 6. With these two equations, I would like to solve these two equations by the addition method. To solve these two equations by the addition method, I must make one of the letters cancel. I'm going to go after the y term because I've got 4y being negative already. That means all I have to do is take the first equation and multiply the y in it by 4. And so, in my system of equations, I'll multiply the first equation by 4, the second equation by 1, and write the second equation in the new order that I've come up with, 3x minus 4y equals 6. So, we get, from the first equation, 4x plus 4y equals 120. Multiplying this one by 4, we get 4x plus 4y equals 120. Then 1 times the second equation. Remember, I'm using the form of the second equation that's here in my concluding version. 1 times this equation gives me 3x minus 4y equals 6. So here's my pair of equations set up, ready to be solved by the addition method. Of course, now the y terms will cancel, and that leaves me 7x on the left-hand side of the equation and 126 on the right. So 7x equals 126. To find x, I simply divide by 7. And with the help of a little calculator work or division out in the scratch margin, I divide 7 into 126 and get 18. This means that the x value is 18. To finish solving the system of equations, I'll take my x value of 18 and substitute it into one of the paired equations. I'm going to choose the first equation, fill in 18 in place of x in the first equation. And so I'll have 18 plus y equals 30. 18 plus y equals 30. Then to get y by itself, all that's left is to remove the 18 that's added. We'll subtract 18 from both sides and get 18 plus y subtract 18 equals 30 subtract 18, which tells us that y is equal to 12. So we've solved the system of equations, and we've got x is 18, y is 12. Is that it? Well, not quite. Before we stop with this, we must go back to the names that were given to these letters, fill in the numbers we've found, and find out whether the answer checks. So let's take the 18 for x and the 12 for y and go back up to where we set up what x and y stood for. Remember that x stood for the larger and y stood for the smaller. The x value I've just found is 18. The y value is 12. Is 18 indeed larger than 12? Of course it is. So 18 is larger than 12, which is the smaller. That part makes sense, but we must check the problem.